Okay, so let's begin from this page number 16. So Brahmagupta, he was a 7th century astronomer and a mathematician born in Rajasthan. So he was known for his book called Brahmasputa Siddhant, in which he declared that all the things gravitate towards Earth. So I mean, he had given the earliest kind of idea about gravity. Brahmasputa Siddhant declared that all the things gravitate towards Earth. And Brahmagupta was his name. The name of his work was Brahmasputa Siddhant, the 7th century astronomer from Rajasthan. Then Mercury and Venus, they have no satellite. Saturn have the maximum number of not the maximum but the second maximum number of satellites after Jupiter, which has 79 number of satellites. Now Mars has only 2 satellites. Of course you need to remember these exact number of satellites because these planets are unique in terms of their satellites. Jupiter 79, Saturn 62, Mars 2, and the name are Phobos and Deimos. Then power is basically work done per unit time, and its unit is watt. So 1 horsepower is 746 watt, whereas 1 watt is 1 joule per second. So 1 joule of work done per second, that is basically 1 watt. What is the unit of power? What is the unit of power? Okay, right. So power is work done that is measured in joules per unit time. So time is measured in seconds. So joule per second can be the unit of watt. So 1 watt is 1 joule per second. All right, that is how we are going to define that. And dyne dyne, I think that is the unit of force in the CGS system. So we usually follow the SI system overall everywhere, but in terms of CGS system, the unit of force is dyne dyne. Impulse is nothing but force into time, and its unit is Newton second. 1 light year is 9.46 into 10 to the power 15 meters, or I think that should be mentioned in the kilometers. 9.46 into 10 to the power 15 meters, or I think that if we convert that to kilometers, it will be 9.46 into 10 to the power 12 kilometers. Is it? So let us ask 1 light year in kilometers. Okay, that is yes, into 10 to the power 12. 9.46 into 10 to the power 12. All right, then moving on. So that was the 1 light year. Then 1 mole is 6.023 into 10 to the power 23 particles, right? So you have to remember this thing, especially the power that is raised on the 10 in terms of 1 light year. It was, I think, 9.46 into 10 to the power 12 kilometers, or you can say 10 to the power 15 meters. In terms of 1 mole, there are 6.023 into 10 to the power 23 particles. Then we have 1 parsec. What is parsec, by the way? Parsec is 3.26 light years. That's even a larger unit. I mean, there are several light years here. 3.26 light years are there in 1 parsec. Then we have 1 centimeter, that is 0.39 inch, and 1 feet, that is 0.3 meters. Okay, 1 feet is 0.3 meters. 1 feet is 0.3 meters, and 1 meter is how many feet? Better write that down as well. So 1 meter in feet, 3.28. Okay, so I think you should write that 1 meter has 3.28 feet. Okay, so yes, I will write that 1 meter equals 3. Okay, so 1 meter has 3.28 feet, and through that you can even calculate like 1 feet has how many meters. I think 0.3 meters are there. 0.3 meters are there in 1 feet, and 3.28 feet is there in 1 meter. And 1 centimeter has 0.39 inches, or we can say it's better to write like how many centimeters are there in 1 inch. So 1 inch in centimeters, that is 2.54. Okay, 2.54 centimeters. All right, so 1 inch equals 2.54 centimeters. Now that is also clear. तो यहाँ पे हमने 4 चीज़ों के बारे में देखा था. 4 चीज़ों के बारे में पहला क्या देखा कि एक मोल में कितने पार्टिकल्स होते हैं? 6.023 into 10 to the power 23 particles. Then we read about light year. So that is 9.46 into 10 to the power 12 kilometers. Okay, and then we read about 1 horsepower is 746 watt, and then we read about the number of satellites of Saturn, 62, Jupiter 79, and Mars 2. Then we read about dyne, that is the SI unit, CGS unit of force. Then we read about impulse. Then 1 light year is 9.46 into 10 to the power 12 kilometers, or 9.46 into 10 to the power 15 meters. And then 1 mole is 6.023 into 10 to the power 23 particles. Okay, then 1 parsec is 3.26 light years. 1 centimeter is 0.39 inch. You can say that the other way, like 1 inch has 2.54 centimeters, or you can say that 1 meter has 3.28 feet. 1 meter has 3.28 feet. Okay, then candela is luminescence intensity को नापने के लिए एक unit होती है candela. But the condition is that the radiation should be monochromatic in a given particular direction. Only then candela unit can be used to measure the intensity of light, the monochromatic radiation in a single direction. Then astronomical unit is like the distance between the Earth and the Sun is often described as the astronomical unit, and that is 150 million kilometers. Million is basically 10 to the power 6, so always remember that. And so 150 into 10 to the power 6 kilometers, you can write it like that, or you can write 15 into 10 to the power 7 kilometers, or 1.5 into 10 to the power 8 kilometers. Okay, but the basic definition is that the astronomical unit is described as the distance between Sun and the Earth, that is 150 million kilometers, where 1 million is 10 to the power 6 kilometers. Now, a man is standing on a sensitive balance. If he inhales deeply, the reading on the balance decreases. Really? A man is standing on a sensitive balance. If he inhales deeply, the reading on the balance decreases. Wow, that's another question that is very interesting. Now, simple machine does same work in lesser effort. It does the same amount of work, but with lesser effort. Okay, then pressure, energy, and work. Pressure, energy, as well as work. Even the pressure, pressure, we often think that it's a vector quantity, but actually pressure is a scalar, whereas momentum is a vector quantity. So there are a couple of things that I want to clarify, whether pressure is a scalar or vector quantity. So is pressure a scalar quantity? Yes, pressure is a scalar quantity, and it has no direction, it only has a magnitude. The other thing that man or decrease, what is the answer to this question? The reading actually decreases. This is due to the fact that if you apply less pressure to the scale when you inhale deeply, but when you inhale out, you apply more pressure on, and hence the reading on the scale decreases. I need to ask that from ChatGPT. I'm not convinced with that explanation. Okay, so a man stands on a sensitive balance and inhales deeply. Will his weight increase or decrease? When a man stands on a sensitive balance and inhales deeply, his weight will slightly increase, but this change is extremely minimal and temporary. Here's why. Inhaling air, when he inhales deeply, air which contains mass enters his lungs. This adds a small amount of mass to his body, which the balance can register as a slight increase in the weight. However, the difference is very small because air has a very low density. The overall change in the weight will not be significant. Once the air is exhaled, his weight will return to its previous state. But the important thing is that जब हम inhale कर रहे हैं हवा अंदर, the weight should slightly increase, right? That's what ChatGPT is saying. But what about here? A man is standing on a sensitive balance. If he inhales deeply, the reading on the balance decreases. The reading on the balance decreases. So ChatGPT has given a wrong answer. What happens to the reading of a sensitive balance? The reading decreases. This is due to the fact that if you apply less pressure to the scale when you inhale deeply, we apply less pressure on the scale while inhaling deeply, and that's because of which the weight decreases. But when you inhale out, you apply more pressure on the balance, and hence the reading on the scale decreases while inhaling. Acha, theek hai, so I'll remember that. The other thing that I wanted to ask is in a room, if the door of a refrigerator is opened, will the room become warmer? So in a room, so the answer to that is, if the door of a refrigerator is left open in a room, the room will actually become warmer over time. Here's why. So heat transfer in the refrigerator. A refrigerator works by removing heat from its interior, and expelling it into the surrounding environment, that is the room, through a heat exchanger at the back. When the door is closed, the fridge keeps the inside cool by absorbing heat and releasing it into the room through this system. When the door is opened, the refrigerator continuously tries to cool the inside, but since it's exposed to the room's air, it ends up taking in the room's warm air and working harder to expel that heat. Energy inefficiency, the motor and compressor will work constantly, producing even more heat. This heat will be released into the room, causing the overall temperature to rise. So that is the reason. Okay, but in one word answer, you can remember that if you leave the door open of a refrigerator, the room will actually become warmer, right? Then when a ship enters a sea from river, it rises a little. When a ship enters a sea from river, it rises a little because the density of seawater is greater than that of the river. So again, a good question. A body weight is least in hydrogen amongst materials like air, nitrogen, hydrogen. A body weight is least. Our body weight is least in hydrogen amongst materials like air, nitrogen, and hydrogen. So if a body's weight is measured, the answer to that question, a body will weigh the least in hydrogen compared to the air or nitrogen. This is due to the buoyant force which is dependent on the density of the fluid in which the object is submerged. So buoyant force, according to the Archimedes principle, an object submerged in a fluid including gases like air, hydrogen, or nitrogen experiences a buoyant force equal to the weight of the displaced fluid. The denser the fluid or gas, the greater the buoyant force. So air is denser than hydrogen. Nitrogen, which makes up about 78% of the air, is also denser than hydrogen. Hydrogen is the least dense gas among the three. Since hydrogen is less dense than air or nitrogen, it will provide less buoyant force, which means the body will experience the greatest reduction in its effective weight in hydrogen. However, because hydrogen has the lowest density, the body's weight will still be the least when measured in hydrogen compared to the other gases. So that is the answer and the explanation. So our body's weight is least in hydrogen amongst materials like air, hydrogen, or nitrogen, right? Then it is easier to swim in sea water as it is salty and provides an aiding upthrust, right? Just तो यहाँ भी वही reason लगेगा जो ship अगर अब जाती है, when a ship enters a sea from river, it rises a little because the density of sea water is greater than that of the river. If an object floats in water at 4 degree, that is the maximum at which the water's density is maximum. Water's density is maximum. What are you saying? So its volume is minimum. Okay, right. So if an object floats in water at 4 degree, it will sink if the same water turns 100 degree. Because 100 degree पे क्या होएगा कि उसकी डेंसिटी बहुत कम हो जाएगी, तो वो डूब जाएगा. ठीक है, यही तो है ना वाटर की. फिर उसके ऊपर क्या होगा, उसकी डेंसिटी वो एक्सपैंड होने लगेगा. तो एक्सपैंड होगा यानी उसकी वॉल्यूम बढ़ेगा, तो डेंसिटी घटती जाएगी. केवल 0 से 4 डिग्री तक गर्म करने पे उसकी वॉल्यूम एक्चुअली घटेगा और डेंसिटी बढ़ेगी. ठीक है, तो 4 डिग्री पे अगर वो तैरेगा तो 100 डिग्री पे डूब जाएगा. देन एन आइस क्यूब इज फ्लोटिंग इन अ ग्लास ऑफ वाटर. व्हेन इट मेल्ट्स द वाटर लेवल रिमेन्स द सेम. ओके, आई नो दैट. वाइल फ्लोटिंग इन सी, व्हाट पार्ट ऑफ एन आइसबर्ग इज अबव द सी वाटर. सो इसको भी रट लो, 1/9 होता है हमेशा. देन 200 ग्राम ऑफ वाटर इज फिल्ड इन वेटलेस बलून. इट्स वेट इन वाटर विल बी 0. 200 ग्राम ऑफ वाटर इज फिल्ड इन वेटलेस बलून. इट्स वेट इन वाटर विल बी 0. ठीक है, क्योंकि दोनों का सेम है ना डेंसिटी, तो फिर वेट क्या लगेगा, फिर कुछ नहीं लगेगा. एन आयरन नीडल फ्लोट्स ऑन वाटर सरफेस ड्यू टू सरफेस टेंशन. अ नीडल सिंक्स इन वाटर whereas ship made of iron floats because the relative density of needle is more than that of the water displaced by it. Iron, हाँ ये बहुत अच्छा point है. A needle sinks in water whereas the ship made of iron floats because the relative density of needle is more than the density of water displaced by it. ठीक है. Then iron nails float on mercury because mercury is more dense than iron. ठीक है. An iron needle floats on water because of the surface tension. यही हो सकता है. ठीक है. बाकी iron needle sinks in water whereas the ship made of iron floats, तो उसका मैंने बता दिया, because the relative density of needle is more than that of the density of the water displaced by it. Now water has maximum density at 4 degree centigrade, and actually water has minimum volume at 4 degree Celsius. Okay, minimum volume होगा तभी maximum density होगी. Okay, then increasing the amount of substance does not change its density. Increasing the amount of substance does not change its density. What do you mean by that statement? Increasing does not change its density. Please explain that. That increasing the amount of a substance does not change its density. Here's the reasoning. Density is defined as the mass of a substance per unit volume. If you increase the amount of substance, both the mass and volume will increase proportionally, assuming the substance physical properties like temperature and pressure remain the same. Thus, since both the mass and volume increase at the same rate, the net density, that is the ratio of mass to volume, stays constant. क्योंकि हाँ दोनों बढ़ गया ना. Increasing the amount of substance does not change its density because वो उसका मास भी बढ़ाएगा और उसका वॉल्यूम भी बढ़ा देगा. ठीक है, इसलिए ये नहीं, ये मतलब सही बात है. तो ये सब हो गया, ये हो गया पेज. ठीक है. Then fish can survive in frozen lake because water does not freeze at the bottom. Water never freezes at the bottom. As water near bottom is at 4 degree, मतलब warmer than the surface पे जम जाता है, नीचे नहीं जमता है. मान लो नीचे 3 या 4 डिग्री पे होता है, तो 4 डिग्री पे क्या होएगा? It remains in the liquid state. And why is that? Because it has a water at 0 degree. Imagine water at 0 degree and then imagine water at 4 degree. ठीक है, तो वाटर एक्चुअली कॉन्ट्रैक्ट करता है. कॉन्ट्रैक्ट करेगा इसका मतलब वॉल्यूम कम हो रहा है, डेंसिटी ज़्यादा होगी. ठीक है, तो एंड रिमेन्स इन लिक्विड स्टेट ऑल्दो मोर डेंस दैन द आइस अबव. तो water near the bottom is at 4 degree, that is warmer than the surface. Water near the bottom is at 4 degree Celsius. ठीक है, अभी मैंने क्या बताया था कि water has minimum volume at 4 degree Celsius. minimum volume होगा at 4 degree Celsius, तभी तो maximum density होगा. ठीक है, तो minimum volume है नीचे, volume कम है, इसीलिए डेंसिटी ज़्यादा है. ठीक है, और 4 डिग्री पे की बात कर रहे हैं, 4 डिग्री पे डेंसिटी ज़्यादा होगी. तो वाटर एट द टॉप इज़ मोर डेंस, जबकि नीचे वाटर एट द टॉप इज़ लेस डेंस कंपेयर टू द वाटर एट 4 डिग्री सेल्सियस. तो फिश कैन सर्वाइव इन फ्रोजन लेक बिकॉज द वाटर डज नॉट फ्रीज एट द बॉटम. अगेन एक वर्ड में अगर बताएं तो एनोमलस एक्सपेंशन ऑफ वाटर है भाई. इन अ स्ट्रीमलाइंड मोशन द स्पीड ऑफ लेयर्स ऑफ वाटर इज़ लोएस्ट where it touches the pipe. In a streamlined motion, the speed of layers of water is lowest where it touches the pipe. ठीक है. According to Bernoulli's, if there is a hole at the center of a completely filled vertical water tank, according to Bernoulli's principle, if there is a hole at the center of a completely filled vertical water tank, it allows to ooze out from its side wall. The discharged water's trajectory will be farthest for the hole that is located at the center of the side wall. Again, very interesting point. The discharged water's trajectory will be farthest for the hole that is located at the center of the sidewall. Okay, now this also was proved by Bernoulli. Okay, now hydraulic brakes. So this hydraulic brakes use the Pascal law. Pressure exerted anywhere in a confined incompressible fluid is transmitted equally in all directions throughout the fluid. That is the principle upon which the hydraulic braking systems have been developed. That uses the Pascal law, which states that pressure applied on a confined liquid, which cannot be compressed anymore. That's why we are saying that it's incompressible fluid. So the pressure exerted anywhere. Now you get to the point where it cannot be compressed any further. After that, if you apply even a single incremental more pressure on the system, it will be exerted equally upon all directions from within that system outwardly. And that is on the basis of which the hydraulic braking systems have been developed, that is using the Pascal law. While traveling by plane, ink of the pen starts to flow due to the low atmospheric pressure at the high altitude. Again, that is I think that is quite intuitive. Then when an air bubble at the bottom of lake rises to the top, it will increase in size. So when an air bubble at the bottom of lake rises to the top, it will increase in size. And why is that? So air bubble so why does that happen? Yes, an air bubble released from the bottom of a lake increases in size as it rises to the top. This is due to the change in the pressure and behavior of gases in response to those changes. At the bottom of the lake, the water pressure is much higher due to the weight of the water above. As the bubble rises, the pressure from the surrounding water decreases. And then there's this Boyle's law. According to Boyle's law, for gases at constant temperature, the pressure and volume of a gas are inversely related. Pressure and volume of gas are inversely related if the temperature is constant. So pressure and volume of a gas. So pressure and volume of a gas are inversely related. So you can remember that Boyle's law. I can actually paste that. Okay. So you can write it over here. Boyle's law. Okay, then moving on. So kerosene rises in the wick of the stove due to surface tension of oil. Similarly, if a fluid rises more compared to water in a capillary tube, it means that the surface tension of that fluid is more than that of water. Examples of this phenomenon is called capillarity. So examples of capillarity due to surface tension: blotting of ink, rising underground water. Rising underground water is also an example of capillarity. Blotting of ink, spread of water drop in cotton cloth. But rising of water from roots is not entirely due to capillarity. Okay, rising of water from roots is not entirely due to capillarity. Remember that. So I'll just highlight that with a different color, because rising of water from roots is not entirely due to capillarity. Remember that. If capillarity was absent, difficult to use kerosene lamp blotting paper would fail to function. Big trees would not have grown. Even the big trees would not have grown. Okay, so it is necessary, I mean, to an extent, yes, rising of water from roots does occur to an extent due to capillarity, but not entirely due to capillarity. It does play some useful role, but not entirely. So if capillarity was absent, blotting paper would not function. Use of kerosene lamp would not have been possible. Big trees would not have grown. Now, if two soap bubbles of different diameter come in contact, smaller bubble will become smaller and larger will be larger, as there is always an excess pressure inside the bubble, which is inversely proportional to the radius of the bubble. Smaller bubble will have more pressure within. Okay, so as there is always an excess pressure inside the bubble, which is inversely proportional to the radius of the bubble. So अगर radius कम है तो excess pressure inside किस में ज़्यादा होगा? Smaller, क्योंकि inverse relation है ना. तो there is always an excess pressure inside the bubble which is inversely proportional to the radius of the bubble. So smaller bubble will have more pressure within. ये भी एक, तो यहाँ से हमको दो बात पता चल रही है. एक तो कि the smaller bubble will have more pressure within, और दूसरी बात कि if two soap bubbles of different diameter come in contact, the smaller bubble will become smaller and the larger will be larger. ठीक है, तो ये दो बातें मुझे पता चल रही हैं. Then kerosene oil spreads on water because its surface tension is less than that of the water, and it remains floating atop water because it has less density than water. ठीक है, तो its surface tension is also less and its density is also less. ठीक है, kerosene oil. The tendency of a liquid drop to contract and occupy minimum area in the form of a drop is due to the surface tension. Elongation of the wire directly related to the length of wire and inversely related to the square of the radius of the wire. So अगर तुम एक wire को elongate करोगे, elongation of wire is directly related to the length of the wire. तो जितना ज़्यादा length बढ़ेगा उतना elongation हो जाएगा, लेकिन जितना elongation करोगे उतना radius कम होगा, और वो भी स्क्वायर के रेट से कम होगा. तो ये याद रखना. ठीक है. देन द एनर्जी ऑफ विंड इज़ प्योरली काइनेटिक. ठीक है, प्योरली काइनेटिक होती है. देन मास टू हीट एनर्जी, ये न्यूक्लियर रिएक्टर का काम है. केमिकल से हीट एनर्जी बनाना, दैट इज़ फ्यूल कंबशन, और मास से हीट एनर्जी बनाना, सो दैट इज़ न्यूक्लियर रिएक्टर. So a man standing on a completely frictionless surface can propel himself simply by whistling. Also, if no external force acts on the system, its momentum cannot be changed. ठीक है, तो अब हम यहाँ से if the roughness of the road, यहाँ से अब अगले वीडियो में देखते हैं.